Okay, let's go for another chain rule example and step up the difficulty a little bit. Here we have f of x equals the square root of cosine of x squared being the angle. This is a multi-step chain rule, but it's not too bad here. So, starting with rewriting this square root to everything to the 1/2 power. That's what you're going to want to start with here, just to make your life simpler. So f prime of x, using chain rule, we're going to start with the outside and work our way in. Starting with the outside shell, you have 1/2 inside cosine x squared to the negative 1/2 power. Just the power rule, leaving the inside the same. Next, you're going to multiply by the derivative of the inside. The derivative of cosine of x squared is also another chain rule, so you have another shell. Your next outermost shell is going to be cosine, which we know the derivative of is negative sine. Remember, the inside stays the same. So negative sine x squared. And finally, we're going to multiply by the derivative of the most innermost portion, which is x squared, and we know the derivative of that is just 2x. And there you go. That problem is complete other than a little bit of simplification. Here we have a 2 here and a 2 here, so they're gone. So we're left with an negative x sine x squared over the square root of cosine x squared. And we go from here to here, and it means exactly the same thing. Remember, the negative 1/2 power just means it's in the denominator, and the 1/2 power means it's the square root. Also, I combined the 2's. The x with the 1 is still x, and the minus sign there, so we can make that a negative x. And the sine x squared is still in the numerator. So that is the derivative of that using multiple steps of chain rule. Okay, let's go over some more moderately difficult chain rule problems. This is an example of the cube root of secant hyperbolic x plus e to the 2x, and we want to find the derivative of this. Sounds bad, but it's not as bad as you'd think, because chain rule never changes. You're only multiplying the derivative of the outside times the inside and working your way in. So here, keep in mind the cube root can be rewritten, and let me just go ahead and do this. The cube root is obviously can be rewritten as the 1/3 power. So that makes things a little easier to see here, and knowing that, we can more easily identify our shells here that we're using for chain rule. So the outside in step 1 is going to be the 1/3 power. Remember, that's just going to be power rule. The next step is going to be, working your way in, is going to be the secant hyperbolic derivative. Then you're going to do the derivative of the angle. And then snuck in there, you're going to have a chain rule in that e to the 2x. So this is a quadruple chain rule. However, the basic rules still apply here, so there's nothing to really be worried about. So f prime of x, to start with, we're going to start with the outside and work our way in. Using power rule, we know that the 1/3 is going to come out front. 1/3 secant hyperbolic. Remember, the inside does not change. X plus e to the 2x. To the negative 2/3 power. Remember, 1/3 minus 1 is negative 2/3. Alright. There we go. Negative 2/3 power. Let me write this. Okay. So that's the first step done. Now let's work on way in. The next step is the derivative of secant hyperbolic, which is negative secant hyperbolic angle x plus e to the 2x, remember that does not change, times tan hyperbolic angle x plus e to the 2x. Okay, there we go, and that is just from your trig hyperbolic functions, and that is your derivative of secant hyperbolic. Now remember, that's the derivative of the outside. Let's work our way in. Time to multiply by the derivative of the inside of that, which is this section, the angle x plus e to the 2x. The derivative of x plus e to the 2x is 1 plus And here we have e to the 2x. Remember, that's its own separate chain rule because e is not just to the x. So the derivative of e to the x is e to the x, or in this case e to the 2x, times 2. Remember, multiplying by the derivative of the inside, the derivative of 2x is just 2. And there we go. That is the answer to this problem. Looks crazy, but that's truly what the answer to this problem is. It can be simplified a little bit here and there, probably. For example, the 2e to the 2x. You know what? Let me just go for it. So we have a secant hyperbolic x plus e to the 2x and a negative secant hyperbolic. You know what? If it isn't broke, don't fix it. So that's pretty much going to do it here. And this is a perfectly acceptable answer. That is the derivative of this mess using chain rule. The basic rules apply, nothing's different. And just remember to start from the outside and work your way in an orderly fashion. And you'll be able to do any chain rule you can think of.